Hello, calculus fans. Okay, so let's let R be the region under the graph of f of x equals cosine x, above the x-axis, but between 0 and pi over 2. We're going to revolve this region about the y-axis to obtain a solid, and we'd like to find the volume of this solid. Here's a picture. We're going to slice this thing parallel to the axis of revolution. You can see the delta x slice in there. So we have to compute r, that's the distance from the slice to the axis, and that's just an x distance, nothing fancy about that. There's the height, which is just cosine x, that's the height of the slice, and so delta v is 2 pi times the radius times the height times the thickness. So delta v is 2 pi x cosine x delta x. So everything we're doing here, this is the shell method. Alright, we're ready to calculate the volume. So the volume is 2 pi times the integral from 0 to pi over 2 of x cosine x dx. This we'll need to integrate by parts. So following the detail rule, u is equal to x, dv equals cosine x dx, du is dx, and then we anti-differentiate the dv to get sine x. Okay, so we put everything together. We'll get uv, so we'll have a 2 pi x sine x, so I'm just keeping the 2 pi in there. That's evaluated from 0 to pi over 2, minus 2 pi times the integral from 0 to pi over 2 of v du, so that's sine x dx. Alright, that second integral is pretty easy, so we just end up with 2 pi times x sine x plus cosine x, that's evaluated from 0 to pi over 2. And if you plug everything in, this is what you'd get as your final answer. Okay, that's all for now.